All right, so let's tackle our last topic. Now that we understand dot products, we can see how to apply them to real-life situations. The most common application of the dot product of two vectors is in the calculation of work. So from physics, we know that work is done when an object is moved by a force. When the force is constant and applied in the same direction the object moves, we define the work done as the product of the force and the distance the object travels. Work is equal to Fd. We saw several examples of this type in earlier chapters. So now imagine the direction of force is different from the direction of motion, as with the example of a child pulling a wagon. To find the work done, we need to multiply the component of the force that acts in the direction of the motion by the magnitude of the displacement. So the dot product allows us to do just that. If we represent an applied force by a vector F and the displacement of an object by a vector S, then the work done by the force is the dot product of F and S. So here's the definition. When a constant force, F, is applied to an object, so the object moves in a straight line, from point P to point Q, the work done by the force acting at an angle from the line of motion yep, right. The work done by the force F, the work W done by the force F, acting at an angle theta from the line of motion is work is equal to force times the vector PQ, which is equal to the magnitude of the force times the magnitude of our motion PQ times cosine of the angle between them. All right, so let's revisit the problem of the child wagon introduced earlier. Suppose a child is pulling a wagon with a force having a magnitude of 8 pounds on the handle at an angle of 55 degrees. So if the child pulls the wagon 50 feet, let's find the work done by the force. Let me go ahead and copy this image in. So we know that the work is equal to the magnitude of F times the magnitude of our distance, like that distance that we're traveling, times cosine of the angle between them. So in this case, we're given that the magnitude of our force is that 8. Our vector PQ is right here. And our angle is 55 degrees. So the work done in this case is approximately 229 foot-pounds. In US standard units, the measure of the magnitude of the force in pounds, the magnitude of the displacement vector, the magnitude PQ, tells us how far the object moves, and that's measured in feet. So that's actually how we get our units, foot-pounds. The customary unit of measure for work then is a foot-pound. So 1 foot-pound is the amount of work required to move an object weighing 1 pound a distance of 1 foot straight up. In the metric system, the unit of measurement of the force is the Newton, and the unit of measure for magnitude for work is a Newton meter or a joule. So we'll have different terminology depending on what class you're in. All right, let's go ahead and tackle this example 2.31, calculating work. And I believe this is our last, example of this section. So let's give it a shot.